As a track maintenance manager for one of London's busiest railway sections, a key part of my role was ensuring the track's safety for daily train travel. But how do we maintain this level of safety, day in and day out, through regular inspection? In this video, I'll walk you through the various types and levels of inspections performed on the railway infrastructure, and how each one plays a role in ensuring the safe daily movement of trains, passengers and freight. We'll cover the 6 types of inspections, what each type focuses on, the process behind each, and how they combine into a comprehensive inspection regime. Plus, I'll show you how advances in technology are transforming track inspection for the future. Welcome to the P-Way Engineer, the track and railway engineering YouTube channel. Any inspection regime is fundamentally about managing risk. At its core, an inspection seeks to identify risks, assess their severity, and then take actions to control them. This approach applies across contexts, whether it's railway infrastructure, your car, or even your health. Identify issues, uncover their causes, and mitigate or remove them. In railway maintenance, there are 2 primary categories of risk. First, safety risks. Likely the type that comes to mind first. This refers to risks that can endanger the safety of trains and passengers. Then, there are performance risks, which are risks to the punctual and reliable operation of the train service, such as signal or point failures. While systems may prevent these issues from posing direct safety hazards, they can still result in delays or cancellations. Then, sneaking in as a third risk, and secondary to those first 2 primary risks, there is asset life risk, a type that may not have immediately come to mind. Asset life risks are factors that shorten the lifespan of the railway infrastructure assets, whether due to reducing original specifications, deferring maintenance or renewal, or making a choice not to address an issue that exists. Often, these risks arise from decisions balancing asset longevity against the cost of doing the work. I wanted to explain this so you can think about what risk type is being addressed when we discuss each inspection type and its level. Let's start at the base, the foundation, the basic visual inspection, or BVI. Traditionally, a BVI involves inspection staff walking the track, observing it as they go. The purpose is to identify immediate or short-term issues that might need addressing within 4 weeks. How often a section needs to be inspected is driven by a number of main factors. Track construction type. Newer track construction types, such as concrete sleepers with continuously welded rails, generally require less frequent inspection than older jointed tracks or tracks with timber sleepers. Usage level. Heavily used tracks are more likely to develop faults. In the UK, track sections are classified based on annual tonnage and line speed, which influences the inspection frequency. Track features. Plain line needs fewer inspections than switches and crossings, and the switch and crossing construction type and its complexity then also needs to be factored in. In the UK, inspection frequencies range from once a week to once every 8 weeks, depending on these factors. Let me know what the standards are like where you are in the comments below. Though it seems straightforward on paper, creating an inspection plan can be complex. For most of railway history, an inspection plan has been a puzzle of designing walks for inspectors that could be realistically done in a shift, looking at how often those inspections have to be done, factoring in any hard to access parts of the track, and then the number of inspectors that you have that could do the walks. Now, however, recent changes to working practices in the UK mean all inspections have to be undertaken when lines can be blocked. This makes things a whole lot more complicated. Naturally, it pushes towards more inspections being done at night. This is less than ideal, as things are more easily missed in the dark. But technology is changing things. Keep watching to find out how. Let me know in the comments how this inspection type is done where you are in the world. The next level above BVI is the supervisors or managers inspections. Undertaken less regularly than the BVI, this inspection serves a number of different purposes. To check the inspection quality. A key part of the supervisor's inspection is to ensure that the BVI inspectors are doing a good job. It is the supervisor's or manager's chance to get out and look at the track and ensure all the correct issues are being reported as they should be. The manager may also do some more in-depth checks than the BVI, such as gauge and cant readings, or more thorough checks through a junction. These checks can then trigger a detailed inspection if required. More on this later. Then there is the work bank. Given supervisors and managers are key people in the planning of works, these inspections are a chance to review planned works, ensure they are prioritised correctly, and check works that have been completed, or if they're still even required. Lastly, the long-term view. The manager will be looking long-term. How is the track condition? Is it getting slowly worse? Is there a particular trend developing? Is it time to think about proposing a certain area for a renewal or major works? So, that is the bottom of the inspection hierarchy covered. And if you hadn't guessed it, these are classed as safety inspections. Looking over the track at regular intervals to ensure it is safe for trains to run, and then a check on these inspections to make sure they're being done properly. Now, this is not to say that the other inspections we're going to cover aren't safety inspections at all. They all contribute, but especially the BVI is the last line of defence, so to speak, so it's critical it's being done right. The next level of inspections comprises several layers, though they share a single purpose: asset management. These asset management inspections are conducted by area maintenance managers, or track maintenance engineers in UK terms, asset managers or owners, and technical engineering leads, all of whom are doing so to independently assess and review the overall condition of the infrastructure. Track or area maintenance engineers often walk the track directly, conducting hands-on evaluations. However, higher level management may prefer to perform these inspections from the train, allowing a broader view of the infrastructure in real time. More of this later. These inspections are another layer of checking on the quality of inspections and work being undertaken by the maintenance organisation overall. Escalated issues then have context. When issues are raised, it is useful for people such as asset managers to have some knowledge of the area and maybe the background to understand the broader situation. Long-term renewal planning. It is common for asset managers to be in control of the renewal budget and schedule. These inspections contribute valuable insight that helps in the planning and prioritisation of these renewals and major maintenance. Different perspectives, including different levels and expertise within the inspection process, brings in a wide range of viewpoints and experience to bear. It's common that the senior individuals actually started out in maintenance or on track themselves. So far, the inspections we have covered have been inspecting the whole track, pretty general in nature. They form the backbone of the management of risk. For the next 4 types of inspections I'm going to introduce to you, they're going to be added to the sides of this core that we already have. This is because they support, enhance and expand on the safety and asset management inspections, bringing specific focus in some cases. The remaining inspections have no real overall hierarchy or true interdependence. Detailed inspections. As the name suggests, these inspections are a lot more in-depth and thorough. A detailed inspection will be focused on a specific component, such as a crossing or switch in a junction, or on a specific issue, such as the gauge through a junction, or a repeat twist geometry fault site. Another way to think of a detailed inspection is a targeted assessment of a particular risk or set of risks. For example, in the UK, the 053 inspection addresses the derailment hazards associated with switches, while the 054 inspection checks crossings for wear and damage. Given the nature of a railway junction, with its range of subcomponents and the forces involved, they are an area of greater and different risk, so naturally involve a greater degree of inspection. There is a wide range of detailed inspection, from those requiring specific competencies and set frequencies, to those triggered by issues like reoccurring geometry faults. A common theme, though, is they require measurements to be taken, or gauges to be used, and a higher level of scrutiny. When issues or defects are found, mitigations and responses are defined by the standards. This can range from planning repairs such as welding or component changes, up to signing assets out of use entirely, or implementing a speed restriction. Ultrasonic inspection. The rails are the key interface between track and train. They are subject to the concentrated load from each train wheel. This load causes various stresses and strains within the rail material, leading to wear and damage. This damage could be visible and picked up on the basic visual inspection, but more often than not it's too small to see, or maybe inside the rail itself. This is where ultrasonic inspection comes in. A form of non-destructive testing, or NDT, ultrasonic testing uses high-frequency sound waves to detect cracks, voids and internal defects within the rail. Testing can be done with train-mounted units, commonly referred to ultrasonic testing units, or manually. In practice, a combination is used, with the U-to-U train, which covers large distances at speed, identifying suspected issues that are then verified and categorised by manual testing. They are then marked on site for easy identification. This approach ensures that the manual testing is targeted and as efficient as possible. The primary aim of ultrasonic testing is to find and categorise rail defects early so they can be managed and removed before they deteriorate to dangerous levels. This includes rolling contact fatigue, the rail defect that caused the fatal incident at Hatfield. Similar to the BVI inspections, the line speed and usage of the track determines how often ultrasonic inspections are required. For more on rail defects, you should click the link in the top right hand corner or in the description below to watch my video on all the common types of rail defects. Track geometry. The alignment of the track, both horizontally and vertically, is fundamental for the safe running of trains. Naturally, this means it needs to be subjected to regular inspection. Using specially designed trains is the most effective way to do this for a number of reasons. These trains can cover large sections of track, whilst travelling at speeds similar to other trains. This allows them to run alongside normal timetabled trains, limiting the impact on the overall train service, whilst also inspecting the track under similar conditions to which it operates. It also allows large areas of track to be inspected very efficiently. The track geometry trains can record dynamic readings when the track is under the load of a train. This is crucial to detecting faults such as voiding or twists. Some faults only become apparent when the weight of a train causes the track to deflect or move. Equipped with various sensors, these trains monitor a wide range of parameters, including gauge, horizontal alignment, and vertical alignment. Specific faults are also flagged, with algorithms set to detect issues such as twist, which is a sudden change in vertical alignment over a 3-metre section, or cyclic top, which is repeated dips at a regular interval. So, if you want to know more about the different types of track geometry faults, do check out my track geometry playlist. You'll find videos on gauge, twist, cyclic top faults, along with an introduction to track geometry in general. The link is in the top right hand corner now, or in the description below. The data gathered from these trains is processed and displayed as a trace, with each parameter shown separately. Any readings that fall outside of the specified standards are flagged and a fault is generated. These faults are then passed on to maintenance for mitigation and rectification. Like previous inspections, the frequency of this train-borne inspection depends on factors such as track tonnage and line speed. Cab riding. This final type of inspection also involves using trains, but takes a different approach. In this inspection, the inspector, typically a maintenance manager or engineer, rides at the front of the train, next to the driver. This vantage point allows the inspector to observe the track from the driver's perspective, assessing the ride quality firsthand and identifying any areas that require further inspection or maintenance. So, I hope you can see how these different types of inspections, with their different levels of detail and methods, all overlap and complement each other in ensuring the track on which trains travel is safe and any risks are mitigated. Right back at the start of this video, when discussing BVI, we touched on how inspections are changing. We can see the use of technology such as track geometry recording trains and ultrasonic testing units are reshaping the way inspections are conducted. Less people, more automation. The desire to increase the number of trains running, decrease the time staff spend on track, increase efficiency and accuracy are just some of the factors driving a change in the way inspections are undertaken, especially the most basic inspections. In the UK, BVI has been replaced in part by the plain line pattern recognition train. This uses high-speed cameras and machine learning to spot faults and issues with plain line. Commonly mounted on the same train that records track geometry, it removes the need for staff to walk long sections of plain line. The introduction of AI has opened up other uses of video collected from the front of trains to check for areas of low ballast, line-side vegetation levels, or the visibility of railway signs. Trials of other technology, such as trolleys to measure and inspect S&C, are ongoing and will lead to further innovation and changes in the way the railway is inspected and the risks mitigated. Let me know your thoughts on the way railway inspection is changing in the comments below. Please do hit that like button, don't forget to subscribe, and check out some of my other videos linked on screen now.